In video 2.3, we will answer the question, how do I determine how many moles of each of a chemical substance are in the equation? How many are needed and how many are left at the end? So by the end of this video, you should be able to use dimensional analysis to calculate the moles of various substances in a chemical reaction. Let's start out with something that's a little bit easier than a chemical reaction. Let's start out with a pizza recipe. It all works out the same way. If this is our recipe for an easy cheese pizza, basically 1 crust, 5 ounces of sauce, and 1 cup of cheese is what is needed to make one pizza. We can answer the question, let's say I'm going to have a party, like spur of the moment, I'm having people over. I'm like, oh, we'll make pizza. That's what we'll do to have a snack. And I look in the fridge and I see 4 Boboli crusts, 10 cups of cheese, and 15 ounces of tomato sauce. And I want to know, how many pizzas can I make with these ingredients if I have to follow this recipe? So we can look at each ingredient individually and help make our determination. So if we start with the crusts, we see that we have enough crusts to make 4 pizzas. If we follow this formula like we learned in the last video, 4 crusts times 1 pizza is equal to 1 crust. You can see here, 1 pizza, 1 crust. And then the crusts get crossed out. And we're left with 4 times 1, means we can make 4 pizzas with the amount of crusts that we have in the cabinet. As far as the cheese, we have 10 cups of cheese. For each pizza, we need 1 cup of cheese. So 1 pizza per 1 cup of cheese. We cross out the cheese, and we see 10 times 1 is 10. So we can make 10 pizzas before we run out of cheese. Now, lastly, let's look at the sauce. We said we had 15 ounces of sauce. So we have enough sauce to make 3 pizzas, because 1 pizza needs 5 ounces of sauce. 1 pizza, 5 ounces of sauce. And when we cross those out, we see 15 divided by 5, because 5 is in the denominator this time. We can make 3 pizzas with the amount of sauce that we have. The same procedure is used when we're looking at chemical reactions. Here's an example of a chemical reaction. You can see over here on the left-hand side are the reactants. Those are the things that are going to be combining together to make our product, which is over here on the right-hand side. Another word we need to define is coefficient. That is this number out in front here. So for aluminum, it is 4. For oxygen, it is 3. And for this aluminum oxide, it is 2. That coefficient basically is like the recipe. It tells us how many moles of each reactant we need and how many moles of product we'll get out of it. So just like with the pizza, although this recipe says I need 4 moles of aluminum and 3 moles of oxygen in order to make 2 moles of aluminum oxide. So those numbers work just like they did in the pizza recipe. So let's work out some problems with this. Basically, all we're doing is creating a proportion, just like we did with the pizza. Here's my equation. The first question asks, if 3 moles of oxygen react, how many moles of aluminum oxide form? So here we have 3 moles of oxygen. We get 2 moles of aluminum oxide, because that's what the recipe says. If you have 3 moles of oxygen, you get 2 moles of aluminum oxide. Just like if we had 10 cups of pizza, we would get 10 pizzas. 10 cups of cheese, 10 pizzas. 3 moles of oxygen, 2 moles of aluminum oxide. Now the next question asks, if we have 4 moles of aluminum, how many moles of oxygen will we need? And the answer to that is 3. 4 moles of aluminum, 3 moles of oxygen. That's the ratio, that's the proportion. Just like 5 ounces of sauce, 1 cup of cheese. That was the ratio. Of ingredients, here we have 4 and 3. Now the next question asks, if 4 moles of aluminum oxide are formed, how many moles of oxygen were used? So this time we have to do a little multiplying. Instead of 2 moles of aluminum oxide, what if we doubled that? So instead of 1 pizza, what if we needed to make 2 pizzas? How much sauce would we need? So this time, question number 3 reads, if 4 moles of aluminum oxide are formed, how many moles of oxygen were used? So now we're starting here with my finished product and working our way backwards to look at how much of the reactants were used to make that finished product. So as you can see here, this says for this recipe here, we're getting 2 moles of aluminum oxide. But the question asks about 4 moles of aluminum oxide, which just means we need to multiply everything by 2. Just like the recipe with the pizza said 1 pizza. Well, if we wanted to make 3 pizzas, we would need to multiply everything in our ingredient list by 3. So if we have 4 moles of aluminum oxide, the number of moles of oxygen that were used is 6, because 3 times 2 is 6. Now the last question says, if 8 moles of aluminum react, how many moles of oxygen are needed? With this question, we're looking only at our ingredients, only at our reactants. If we have 8 moles of aluminum, again, for the recipe is only 4, so to get to 8, we multiply by 2. How many moles of oxygen are needed? So again, we also need to multiply this by 2, and we see that 6 moles of oxygen are needed to react with 8 moles of aluminum. Let's do a couple more examples of these that are a little bit more complicated. If this is our equation right here, if this is our recipe, it says I have 16 moles of aluminum plus 3 moles of sulfur, and that makes 8 moles of aluminum sulfate. So then my question says, if 2.5 moles of sulfur react, how many moles of aluminum sulfide are formed? So it's not an easy multiplication like we saw on the last slide, because my recipe says 3. But if I only have 2.5 moles, how many moles of aluminum sulfide am I going to get? So if we work through our problem, first we write down what we're given, 2.5 moles of sulfur, and what we need to find, which is how many moles of aluminum sulfide. Then when we write out our equation, we can just do a ratio. So 2.5 moles of sulfur and 3 moles of sulfur. So this is in the recipe. This is what I'm given in the problem. And that is equal to, we don't know how many moles of aluminum sulfide, over 8 moles of aluminum sulfide. This 8 came directly from the problem right here. So the 3 and the 8 are the ratio in my recipe. The 2.5 and the question mark are the ratio from my problem, what I know and what I'm trying to find out. So when I cross multiply or do the math to work out this equation, I find out that 6.67 moles of aluminum sulfide are formed. So if I have 2.5 moles of sulfur, I will end up with 6.67 moles of aluminum sulfide. Here's my next example. Same equation with the aluminum and the sulfur, making aluminum sulfide. This time the question says, if 3.75 moles of aluminum react, how many moles of sulfur are needed? So this time we're talking about just my ingredients, my reactants, aluminum, sulfur. If I have 3.75 moles of aluminum, how much sulfur am I going to need for this recipe to work? So we'll write down what we're given, 3.75 moles of aluminum, and what we're looking for, moles of sulfur. So then again, we can set up a ratio proportion equation. 3.75 moles of aluminum over 16, which comes from the problem, over, we don't know how many moles of sulfur, that's my question, divided by 3 moles of sulfur, which again is from the question. Then when we cross multiply, work through the math on this one, we get 0.703 moles of sulfur. So that is how many moles of sulfur I need if I have 3.75 moles of aluminum to make this equation or this recipe work out correctly. So think about this question for a minute. It'll probably be asked as an opener in class someday. It says, why do chemists use moles to measure substances? Why aren't grams, liters, and molecules enough? So put some thought into that, and it'll come up in class soon.